Welcome to online lecture series in organic chemistry, and we are discussing about the electronic spectra of complexes. In earlier video we have seen the microstates, and microstates are the allowed combinations of ml and ms values. Now in this video we are going to discuss the determination of ground state term for P2 configuration, that is carbon atom. Now the number of microstates for P2 configuration are 15, that we have seen in earlier video, and we are going to identify all these 15 microstates step by step. Carbon atomic number 6 has the electronic configuration 1s2, 2s2, 2p6. It means in p subshell there are 2 electrons. Now this is the arrangement of electrons or accommodation of electrons in p orbitals. So these are the 3 p orbitals and 2 electrons accommodated in 2 p orbitals, px, py. One orbital is vacant. So value of azimuthal quantum number, that is L, for each electron it is 1 because electron present in p subshell. So L1, this is for first electron, and L2 it is for second electron. So L1 equal to L2, that is equal to 1, and therefore capital L. So this is the one of the quantum number, that is orbital angular momentum quantum number. So this value L, we can find out L1 plus L2, that is equal to, or sorry, L1 plus L2 to L1 minus L2. So L1 plus L2, it is 1 plus 1 to 1 minus 1, that is 2 to 0. So possible L values are 2, 1, 0, because each L value differ from its neighboring value by 1 or unity, and corresponding states are, or state symbols are, DPS. When L is equal to 0, then corresponding state symbol is S. When L is equal to 1, then capital P, and when L is equal to 2, then capital D. So these are the state symbols for P2 configuration. Now there are 2 electrons in p subshell, and the orientations are, this is one orientation, 2 electrons are having same spins, that is clockwise direction, and for these 2 electrons the S, that is the resultant spin quantum number, it is 1. So half plus half, that is equal to 1. Another orientation for 2 electron is 1 electron spin in clockwise direction and second electron spin in anti-clockwise direction. So plus half minus half, that is equal to 0. So resultant spin quantum number, it is 1 and 2. So these are the S values. S values are 1 and or 0 and 1, and L values are 2, 1, 0. Now here most important thing is each of the L value, that is 0, 1, 2, couple with the S values, that is 0 and 1, and we get the several or possible terms, and out of various possible terms few terms are allowed, that we are going to find out. Now these are the L values, that is L is equal to 2, 1 and 0, and these are the corresponding state symbols, that is D, P, S. Now S value, it can be 1 or 0. So these are the 2 S values. Each of the S value couple with L value, that is 2. So when this 1 couple with 2, then the multiplicity for L is equal to 2 and S is equal to 1, especially multiplicity for S is equal to 1, it is the formula 2S plus 1. So here value of S is 1, and therefore multiplicity will be 3, that is triplet. So when S is equal to 1, then there will be triplet. Then possible J values are, so value of J ranges from L plus S to L minus S. So here L is equal to 2 and S is equal to 1. So 2 plus 1, that is equal to 3, and 2 minus 1, that is equal to 1. So value of J, maximum value it will be 3 and minimum it will be 1, and each J value differ from its neighboring value by 1. So possible J values are 3 to 1 for this set of L and S values. Now corresponding term symbols for these 3 J values are, now here L is equal to 2 and therefore symbol is D. Here multiplicity is 3 and J value is 3. So D 3 3, this is the first term symbol for these 4 values, that is L is equal to 2, S is equal to 1, multiplicity is 3 and J is equal to 3. Now for another J value, that is J is equal to 2, the term symbol will be D32. Here only J value will be different, that is 2. And for third J value, that is J is equal to 1, the term symbol will be D31. So for these 3 J values, 3 to 1, corresponding terms are D33, D32, D31. Now consider the coupling of this S is equal to 0 with L is equal to 2. Now first of all, multiplicity when S is equal to 0, it will be 1, because when value of S is 0, then there will be singlet. Okay, now possible J values when L is equal to 2 and S is equal to 0 are, so L plus S, that is 2 plus 0, that is equal to 2, and L minus S, that is 2 minus 0, that is equal to 2. So only one J value is possible for this coupling, that is L is equal to 2 and S is equal to 0, and that is the J is equal to 2. And corresponding term for this set, that is L is equal to 2, S is equal to 0, multiplicity 1 and J is equal to 2, that is D12. So here D stands for L is equal to 2, 1, this is the multiplicity, that is the singlet, and 2, this is the J value. Now this L is equal to 1, that is P state, also couple with S is equal to 1 and S is equal to 0. Now when S is equal to 1, the multiplicity will be 3, that is triplet. Possible J values when L is equal to 1 and S is equal to 1, that is L plus S, that is 1 plus 1, that is equal to 2, and L minus S, that is 1 minus 1, that is 0. So possible J values are 2 to 0. So 2, 1, 0, each J value differ from neighboring value by 1, and therefore possible J values, that is 2, 1, 0 when L is equal to 1 and S is equal to 1. And corresponding term symbols are, for this first set, the corresponding term symbol is P32. Why P? Because L is equal to 1. 3, this is the multiplicity. 2, this is the value of J. Now corresponding to J is equal to 1, the term symbol is P32. P stands for L is equal to 1, 3, it is the multiplicity, and 1, this is J is equal to 1. And for this 0, J is equal to 0, corresponding term symbol is P30. Now again, this S is equal to 0 coupled with L is equal to 1. Before that, multiplicity when the S is equal to 0, it is 1. Because when S is equal to 0, so 2 into 0, that is 0, plus 1, that is 1. Multiplicity is 1. Now possible J values when S is equal to 0 and L is equal to 1, that will be L plus S, that is 1 plus 0, that is 1, and 1 minus 0, that is also 1. So possible J value is 1, and corresponding term symbol, that is P11. So why P? Because L is equal to 1. 1, this 1, it stands for multiplicity, and this, the subscript 1, this is for J value. Okay, now L is equal to 0 also couple with S is equal to 1 and S is equal to 0, and when multiplicity, when S is equal to 1, it is 3, already I discussed. Then possible J values when L is equal to 0 and S is equal to 1, that is L plus S, that is 0 plus 1, that is equal to 1, and L minus S, that is 0 minus 1, that is minus 1, but negative J values are not possible, and therefore only one J value is possible, that is 1, and corresponding term symbol, that is S31. Why S? Because L is equal to 0, corresponding state is S3 is multiplicity, and this 1, it is J value. Now when S is equal to 0 couple with L is equal to 0, then what will be the term symbol? Before that, when S is equal to 0, the multiplicity will be 1, I explained earlier. Then possible J values are L plus S, that is 0 plus 0, that is 0, 0 minus 0, that is 0. So only one J value is possible, that is 0, and corresponding term symbol, it is S10. S, why S? Because L is equal to 0, this 1, it is multiplicity, and this 0, it is for J value. So these are the possible term symbols when L is equal to 2, 1, 0 coupled with S is equal to 0 and 1. But all these term symbols are not allowed. Few term symbols are allowed, and actually these allowed term symbols are based on the selection rules. Okay, now how to find out these allowed term symbols? So here the possible terms are DPS. Just you write DPS. For this set, we have seen here possible multiplicities are singlet and triplet. Singlet, triplet, singlet, triplet. These two multiplicities are possible. So for D, you write singlet. Then for P, triplet. And for S, singlet. So write 1, 3, 1. Or in reverse order, one can write SPD 1, 3, 1. From either side, from any side you start with 1, that is singlet. So 1, 3, 1. So D1, P3 and S1, these are the allowed terms. These allowed terms are based on the selection rules. Now detail about this I am not discussing here. It is out of syllabus, out of scope of this syllabus. And so on the basis of selection rule, these are the possible terms. Now the term D with multiplicity 1 has a term symbol D12. So this is allowed term symbol. Now the term or P with multiplicity 3, for this term the possible term symbols are P32, P31 and P30. So these are the allowed. So allowed I am writing here. And for S1 term, the allowed term symbol is S10. S31 is not allowed because here multiplicity is 3. So this is allowed. So I am writing here. So allowed term symbols are D12, P32, P31, P30, S10. So these are the allowed term symbols, and these, for these allowed term symbols there are 15 microstates. Other term symbols are not allowed, or these are forbidden. Out of various term symbols, these are allowed.